Hello my friends, in this video I am going to teach you how you can write the props section of the Eclipse data file. First I'm going to have some small introduction about the props section, and then we are going to review the main keywords that we need to use in the props section. So why prop section is important? Because in the prop section we are going to give the tell the Eclipse that what will be the PVT of our fluids. So basically in the run spec section we told the Eclipse that we are going to have, for example in this case, gas, oil and water phases. So in the prop section we need to tell the Eclipse that how these phases, I mean gas, oil or water, are changing with the pressure. Okay, mainly with the pressure. So in the prop section, first we need to have a PVT data, and also we need to have a base density. What is the base density? It's the density in the standard condition, the density of each phase in the standard condition. Why it's important? Because if you have the density in the standard condition, so we can calculate the density in the reservoir condition based on PVT data. And also in the prop section we are going to tell the Eclipse that what will be the relative permeabilities in our system, what will be the capillary pressure in our system, and also what will be the rock compressibility in our reservoir. So why is PVT is important? Because as you know, when we are producing from the reservoir, so imagine this is our reservoir, so when we are producing oil from the reservoir, pressure is declining around the well, and the pressure will be different around the well than, for example, rest of the reservoir. When pressure is declining, we know that some gas can release from the oil, and also oil and gas are going to expand due to the less pressure. So the volume of the phases will be changed, and we need to have these changes in our data file. If you remember from the PVT, we are for the different reservoirs, okay, different complex reservoirs, we have a pressure versus temperature curve, and we call this PT diagram. And if we draw the PT diagram for the multi-component reservoir, we are going to have a phase envelope. So in the phase envelope, this line up to critical point will be the bubble point line, and after critical point, this point will be the dew point. So based on the reservoir initial temperature and the pressure, we can say that, for example, this reservoir is a black or volatile oil or gas reservoir. Okay, so why it's important? Because we should know about what type of the reservoir we have. For example, if we have a black oil reservoir, it's most probably that we are going to deal with the solution gas derived and also gas, water and oil phases. But if we have a gas reservoir, it means that we are mainly going to deal with the gas and the evaporated oil in this region. So that's why we need to have some idea about our reservoir. And as you know, for the black oil reservoir, so the reservoir that their initial condition are lying in this section, and the dry gas, we can use a black oil model. But if we have a reservoir that's composition is changing too much with the temperature and pressure, so it means that if the reservoir initial condition are somewhere here, okay, we need to use the compositional simulator. Okay, so our purpose is to find the densities of the different phases, for example gas, oil or water, in the reservoir condition. Okay, so imagine this is a reservoir, but we know that we are producing this fluid and it comes to the surface condition. In the surface condition, it's going to pass from the first stage separator, and we are going to have a phase separation. So it means that we are going to have water, oil and gas, and oil will go to the second stage separator, and again we are going to have another separation, and lately we are going to have a stock tank. And as you know, we are measuring the densities in the standard condition. So it means that this is a standard condition. We have a water density, the oil density, and gas density. So somehow we need to transfer all these densities to the reservoir condition using the PVT data. So that's why we need to have a PVT data in our data file. How Eclipse is converting those data to the reservoir condition to the reservoir condition. Eclipse is using this formula. So in this formula, it means that density of oil, for example, oil phase at the reservoir condition, is the function of the density of the oil at the standard condition, gas oil ratio, and density of the gas at the standard condition divided with the oil formation volume factor. So it means that if we give a Eclipse density of oil and density of gas at the reservoir at the standard condition, and RS and BO for the Eclipse can calculate density of oil at the reservoir condition. And this is exactly what we are going to do in the PVT section. We are going to give the density of the fluids at the standard condition, and also we are going to tell what will be the RS and BO in our system. And this is some terminology that Eclipse is using. For example, as I told you, if we have, for example, fluid in this area, its initial temperature and pressure are in this area, it means that it is a black oil, or we can use dead oil, or if it is in the saturated section, we can use a live oil simulation for these kind of reservoirs. So what is the difference between dead oil and live oil? In the dead oil, we say that we don't have any gas inside the oil phase, but in the live oil, we say that we have dissolved gas in our system. So there's keywords to be used in the dead oil and live oil are totally different, and we are going to cover all these in the next section. And also, if we have any reservoir that its temperature and pressure are in this area, it means that its temperature is more than a critical temperature. It means that we are dealing with a gas reservoir. Okay, gas reservoir can divide into different gas reservoir. For example, in the dry gas reservoir, we don't have any liquid hydrocarbon in the reservoir or at the separator, so we call this kind of reservoir gas reservoir. And if we have some hydrocarbon in the separator but we don't have any gas in the reservoir condition, we call that wet gas. And also we have also retrograde gas condensate. It means that we are decreasing the pressure, we are going to have some condensate. So for totally in general, you can use a black oil simulator for dry gas, wet gas, and the dead oil or live oil. But for the near critical fluid and the retrograde gas condensate, it's better to use a compositional simulator because their composition are changing too much with the pressure. So imagine we are going to simulate dead oil. So dead oil will be our initial pressure and temperature will be here. So for example, you have black oil and very heavy black oil, so you are going to simulate the dead oil. In the dead oil, the first keyword that you need to use is a PVDO. What is a PVDO? PVDO is a keyword that you are going to tell the Eclipse that what will be the BO and the viscosity are how oil formation volume factor and the viscosity are changing with pressure. So it means that you need to have the first item in this keyword is a pressure. So you need to list all the pressures. So it should be in the increasing order. And you need to give the oil formation volume factor and the viscosity in that pressure. For example, in 2500, we are going to have 1.26 for the oil formation volume factor, and we are going to have 0.5 for the viscosity. And you need to provide this table to the Eclipse. Why we need to provide this table? Because this was based on the BO, okay, or formation volume factor, Eclipse can calculate densities. So the first keyword is PVDO, and PVTi is used for the case that you have a dead oil, okay, and it should be a table, and in the format of table, and table is going to finish with a slash. So if you have a different table, you need to have a slash at the end of each table and another slash at the end of the all tables. So the important thing is that if you use PVDO, it means that you are dealing with a dead oil, and the PVDO is taking three items: pressure, oil formation volume, and viscosity. So you need to provide a table for the BO and the viscosity in different pressures. This was the first method to tell the Eclipse about the oil properties for the dead oil. The second method is using PVCDO keyword. So PVCDO keyword is that you don't have a table. So when you don't have any table, for example, you didn't measure all these measurements in different pressures, so you can have one reference pressure, for example, in this case 3600, and in this reference pressure you calculated oil formation volume factor, okay, 1.12, and also you need to give the Eclipse what will be the CO, it means the compressibility of oil. And why we need to give the compressibility of oil? Because based on this compressibility, Eclipse can calculate BO in different pressures. You only provided in the reference pressure, so based on this, Eclipse can calculate every single BOs in different pressures. And also you need to give the viscosity at the reference pressure, okay, and how viscosity is changing with pressure. It's very similar to CO as well, but for the viscosity. So if you want to use PVCDO instead of PVDO keyword, you need to provide reference pressure, oil formation volume factor at the reference pressure, compressibility of oil, and viscosity at the reference pressure, and how viscosity is changing with the pressure. So if you provide all these information to the Eclipse can calculate the PVT properties. The next thing is that even for the very black oil, you may have a solution gas oil ratio. So you need to provide this solution gas oil ratio to the Eclipse, RS. Why it's important? Again, if you back to this formula, we already provided BO. So the next step is to provide RS. Okay. So for RS const is a keyword that you need to use in this situation, and RS const keyword is taking two items. First item is a solution gas oil ratio, RS, so you need to provide that. And the second item is PB, or pressure at the bubble point pressure. Why we need to give the bubble point pressure? Because as you know, for the RS, if you draw RS with the pressure, RS is increasing up to the bubble point pressure, and then it will be constant. So if you provide RS at the bubble point pressure, Eclipse knows that for any pressure above the bubble point, RS will be the same value. So you need to use RS const, and the first value will be RS, and the second value will be the bubble point pressure, and this keyword is ending with a slash. Okay, that was for the dead oil, but most probably you are going to deal with the live oil, because somehow in your system, after a while, pressure will decline, will be less than the bubble point pressure, so you need to provide the data for that one as well. So for the live oil, we also have two methods to give the oil properties for the live oil. The first keyword is PVTO. So in the dead oil we had PVDO, but this one is live oil is PVTO. So what is a PVTO? It's very similar to the previous keyword, but in addition of the pressure, BO and mu, we need to provide RS as well. Why we need to provide RS? Because we know that in the sometime in the later, when pressure declines in the reservoir, we are going to have saturated reservoir, so RS will be changed. So you need to provide that as well, the change of RS with the pressure. So you need to, first item, so this keyword is taking the table. Okay, you need to provide table for this keyword, and the first item will be RS, and it should be in the increasing order. And second item will be pressure. The third item will be oil formation volume factor, and the fourth item will be viscosity. So the table should have undersaturated reservoir section. So all these values are for the undersaturated section. For the saturated section, it means that RS is changing with pressure, and these sections, the rest of the table is for the undersaturated section. It means that the pressure is above the bubble point pressure. So all those values should be provided in the one table. Okay, but the difference is that after bubble point pressure, so the last item here in the saturated section is the bubble point pressure, and we provided the RS for the bubble point pressure. For any pressure above that bubble point pressure, this pressure, we don't need to give RS. Okay, RS section will be blank. So here in our data file, after you have props, you need to, for example, we are going to have a live oil simulation. So we write PVTo. Okay, so PVTo will take a table. Okay, and in this table we provided, for example, PVTo for that table. So if you have if you are sure that your reservoir is not going to your reservoir is a saturated reservoir, so you don't need to have this section. Okay, but if your reservoir is going to will be the undersaturated, and then go with the declining pressure is moving to the saturated section, you need to change this table. Okay, so for example, here in this example, we have a saturated table which is up to 3300, and PVTo or RS for at this pressure is 5. Okay, but if for any pressure after it bubble point pressure, we should leave that as a blank here, so we don't need to provide any value for that. Okay, so this will be your PVTo or the PVT properties for the live oil table. And the next step is to and also I'm going to talk about the next method. So this was the first method that you can have this kind of tables, so PVT for the live oil. So if you want to use the second method, it means that you need to provide bubble point pressure, RS or solution gas oil ratio, oil formation volume factor, viscosity, and how oil compressivity, it means that how BO is changing with the pressure, and CV, it means that how viscosity is changing pressure. So if you provide all these information to the oil, to the Eclipse can calculate that in the different pressures. The next step is to provide the gas to provide the dry gas properties. As you remember, we had the oil phase, gas phase, and the water phase in our system. So we already provided the PVT for the oil phase using PVTo keyword, and we divided that in two tables. First table was for the saturated section, and the second table was for undersaturated section. So we provided all those in the under PVTo keyword. Right now we need to tell the Eclipse that how dry gas is changing, how the gas phase are changing with the pressure. So for that we need to use PVTg keyword. Okay, so PVTg keyword is using for the dry gas, and it's going to take three items. First item will be pressure, so you need to provide pressure at the increasing order. And the second item will be gas formation volume factor, or Vg. And the last item or third item will be viscosity of gas. So you need to provide all these as a table and like this. So you are going to have pressure, Vg, and mu g here, viscosity of the gas formation volume factor, and the pressure, and it's going to finish with a slash. So in your data file, after PVTo, write PVTg. So PVTg means that we are going to provide the dry gas properties, and copy and paste this table in your keyboard, okay? And it's going to finish with the slash as well. So right now we gave the oil properties, gas properties, and the next step is to give the give the water properties, okay? So the next phase is the water, so we need to tell the Eclipse that how water is changing with the pressure. So for water, you need to have a reference pressure, and what is the water formation volume factor, or BW, at that reference pressure. What is the compressibility of water at that reference pressure? It means that how this BW is changing with pressure. And you need to have a viscosity of water and tell the Eclipse that how this viscosity is changing with the pressure. So under PVTW keyword, you need to have pressure, BW, CW, viscosity of water, and how viscosity is changing with pressure. So in your data file, write after PVDG, write PVTW, okay? And you need to provide one reference pressure, water formation volume factor, water compressibility, water viscosity, and how viscosity is changing with the pressure. And these keywords also should finish with a slash. Okay, so you provided the properties of the each phases, oil phase, gas phase, and water phase. Right now you need to tell the Eclipse that how my formation is or my pore volumes are changing with pressure, because as you know, when we are changing the pressure, like will be pressure, if for example, if we decrease the pressure, that pressure reduction will change the pore volumes, okay, pore volumes that we have in the reservoir. So somehow we need to tell the Eclipse that how these pore volumes are changing. To do that, we are using rock. Let me see if I have a slide for the rock as well. No, I don't have it here, so it's okay. So for that we need to use a rock keyword, okay? Rock keyword is taking two items. First item is the reference pressure, and the second item is the compressibility of the rock at that reference pressure. So first, for example, in this case, this is our reference pressure, and we say that rock compressibility will be this value. And also this keyword is finishing with the slash, okay? So you provided oil, gas, water, and the rock properties. So what is the next? If you back to this formula, okay, we already provided RS, BO. So what is missing here? We need to provide the density of the oil and density of gas at the standard condition, okay? To do so, we are using density keyword, okay? So if you use density keyword, so we already had the rock here, so as I told you, rock is taking the reference pressure and the CF, so you can provide that. So you need to provide the density, okay? So this is a density keyword, and density keyword is taking three items. First item is the oil density, second item is the water density, and third item is the gas density, and all these are at the standard condition. So under density keyword, you need to provide oil density, water density, and the gas density at the standard condition. And why it is important? Because if we provide the oil density and gas density here, and we already provided RS and BO, so Eclipse can calculate density of the oil, gas, and water at the standard, at the reservoir condition. So we provided oil, gas, water, and the rock properties, and we told the Eclipse that what will be the densities at the standard condition. So we done with this section. In the next step, we need to tell the Eclipse that how. So if we back to this slide, we done with the PVT data with the pressure, how PVT are changing with pressure. We done with density. So in the next step, we need to provide related permeabilities functions, PC and relative permeability functions. So we need to provide these to Eclipse to start our simulation. For that, so in the next video, I am going to cover the saturation functions